Tumbler time. So we're going to build a tumbler today. So I've been acquiring containers. This is from some, I don't know, my dad had it. And then I got some other containers that I've been acquiring for tumbling, so that I can tumble small parts in a rotary tumbler that spins the tumbler. So in here I'll just put some pieces of angle iron, I'll rivet them through, and it'll run and hopefully agitate enough to polish my parts or deburr my parts. To build this, I have got a little what is this thing? 0.12 kilowatt 3-phase motor with a little 0.2 kilowatt VFD, so I can set the speed and have a decent amount of control on that. I've then got a piece of plywood which I'm going to cut and make a box, 500 by 250, that those will drop into. And I can also put a lid so I can silence the tumbler a bit. So let's get cracking. My design so far is that, literally a piece of paper. So I'm going to probably end up just doing this on the drill press, because it's going to be way bloody easier than trying to put a big piece of plywood into my little CNCs. So I think I'm just going to do the bearing seats on the drill press, try out mark them as accurately as I can and drill them in. It's skateboard bearings, nothing fancy. And then I might have to CNC up a bracket to hold the motor, because that obviously needs to be somewhat fancy. It needs to self-tension if possible. And then I'm probably just going to run like a V-belt or a big O-ring really to run the two rollers. It's nothing fancy. But yeah, let's go cut some plywood.
Look, I've got my plywood here sitting on my sacrificial pallet. As you can see, I've put my saw through it a few times. I'm just measuring the blade distance from the edge of the base, so that I can add that to my measurements. So when I put my fence up, which is that nice straight piece of wood, I end up with the blade being in the right location, even though my fence is over by 49 millimeters, which seems like a random measurement, but that is what my saw's measurement is. My sizes were pretty good. So I'm just setting the depth of the blade here so that I don't cut too deep into my pallet. I did end up finding a nail while cutting. And then just figuring out how I'm going to do this. Just pop it in. There you are. I thought I had it lined up. But yeah, I didn't. Yeah, and then we move over to the next piece magically. And then checking it square, and woo, magic! Next piece.
Okay, two side pieces are screwed together. Put some arcs for where my bottles will sit, that I can still put a lid on the thing. So I need to now poke some holes. So what I've done is I'm going to poke a 6.8 hole through tappet M8, that I can screw a bolt in from here into an 8mm bearing, which will conveniently go nice and tight-ish into this piece of 1-inch tube that I have laying around. So, cutting some costs there. So the 1-inch tube is going to sit like that. I'll probably end up putting some tape on them just to give it some more friction, like a self-vulcanizing tape, rubber tape, so that it'll grip my bottles properly. And then what I'm going to do is probably 3D print some pulleys for this, press them on, that I can just run like a V-belt over it. So I'm going to quickly mark this out and then poke some holes. And then, yeah, it should be over for the bloody way.
Okay, and I'm just poking in some 6.8mm holes right through to swing the part line because of clearance to the pillar. And then here I'm just putting some holes down the end of my plank and counter boring them so that I can screw the whole thing together once I've got all the holes in, giving it a light sand. Okay, and then I'm going to put it together with some chipboard screws. For now I'm just screwing it together. I just wanted to test fit everything before I properly committed to this. From my random assortment of screws that were left over from other projects. But yeah, I got it together with, I think it's 8 screws, and then I added some more later once I glued everything together. Okay, and then over here on the lathe, we're going to turn down the end of this piece of tubing, just so I had to make it a bit shorter. Yeah, I don't have a parting tool that does steel very nicely, so I just literally cut it down with my normal facing tool, and then it rolled the material and I just smacked it off. and then cleaned the end up with the boring bar to find a bearing and fit it. So it's a decent fit. I found the one side tended to be a decent fit, the other side I had to squeeze it down. So I'm trying to almost swage it smaller so that the bearing would be, so I could actually cut and the bearing would be a decent seat. So yeah, you can see me swaging it, just using the chuck to squish the tube a little bit. Okay, and then I'm going to just face it down. What I ended up doing is facing the section down to 25 millimeters for my pulleys to sit on. So I'm just running on the power feed working on the lathe, which is awesome. Yeah, no specific sizes, it's just what I felt like doing. This is kind of a slap together project, and then put the bearing in. Then what I did was I came in from the outside and I actually forced the material in to capture the bearing permanently. So I flared the material around the flange.
Okay, cool. So I got my rollers in. They are on skateboard bearings. They spin nicely. Big tub drops in. It's going to run beautifully. Small tub also drops in. It's going to run awesomely. I don't think this one's going to work. Nope, this guy goes through. But I have got some other plans for some tubs. Unfortunately, I might be able to get 2 of those in. I don't know, we'll have to see. So yeah, that's in now. Then I've got some little wheeliekies, which are going to go here, just to stop tracking. So it'll track against the wheel, it won't rub on the side. And I'll probably tilt the whole thing that way so it runs against the wheel. But yeah, making some progress. I think I want to put that wheel in quickly and then let's see how it looks. So now, perfect. Runs up against the road, and so does this one. Perfect. Okay. Now we're going to do some power transmission stuffs. I need to figure out what I want to do there, and I need to see how I'm going to mount my motor. So now to mount the motor, made up these guys. So these guys will sit like so, and the motor can rest on that. Gives me a bit of shaft clearance, and it should give me a secure enough mounting. So the motor's PCD is 75, so I want to put it quite low. I'm actually going to put it off to the side. So this circle that I'm describing like a bliss, like a major doors apparently. There we go. Okay. Then like this. I'm using a drill bit that's a bit bigger than necessary, so accuracy is not too critical. But now what you'll see is that that hole is up, so that I can get clearance around my pulley to go like that with tension. Don't think that's a drill bit. No, made it my drill bit. There we go. I also only have 3 screws for some reason. My choice of countersunk is so that I get a bit of free not backing outness. Okay, oh, Jesus, okay, I seriously need to glue that box together. I just need to get it assembled first before I do this. Okay, now let's have a look. My screws are not long enough.
So I scrounged around and I managed to find 4 screws that will do the trick if I put a counter bore in. They're not quite screws, they're like stud things that I found. So now attaching the motor with a socket, because they're actually a hex head. So yeah, they sink in and then that attaches. Put a washer and a screw. Spacer, yeah, a bit of a challenge to get it together, but yeah, not the end of the world. I've dealt with more complicated things.
onto it. Yeah, hope it clears. Otherwise, I'll gotta move it. Yeah, it clears. Perfect. Cool. Now I'm gonna make some pulleys and stuff. So what I want to do is this is a Whipper motor. It's a 1000 RPM motor. So I'm going to probably try and gear this thing down quite considerably to these. So I'll probably end up with a big pulley on these guys and a dinky little one on there. Nice, as they say in France.